Okay, class, picking up where we left off at, we put the domain in range, with the domain, which is negative infinity to infinity, and then we also need the range, which is -8 to -4, and -4 is included. Now, here's the thing about this here. I have the visual representation here. I didn't have it in the last video. I added it in for this video here, but you should have saw this on your calculator. So we have the domain. If you notice, there's no restriction on the x values. We cross the negative x values and the positive x values. So this is how we get the negative infinity to infinity. Now, for the y values or the g of x value, if you notice that our -4 here, our y value is as high as it goes. So it'll be negative infinity to -4. It doesn't go beyond -4, but it goes below it. So that is how we get our range. Now we scroll down here to the last page. It says example 3. We have four functions of the form f of x is equal to a times x minus h parentheses squared plus k are graphed on the same scale below. Determine the signs of A, H, and K. Okay, so we look here. If you notice, this graph is facing up. So we know A must be positive. Now, the next thing, our K. Our K, if you notice here, the graph is shifted to the right. So our K must be positive. And since well, actually, our K means that it's lifted up. So since the graph is lifted up, our K must be positive. With it being shifted to the right, that means that our H must be positive. So remember, this is upward, this is to the right, and this is lifted up. Now we go here. If you notice here, our A, which this graph is shifted up, so our A must be positive. If you notice, our graph is not shifted to the left or right. It's staying right here basically in the origin area or the Y area, so our H is 0. And then here, since it has went up from the origin, our K is positive. So that means that the graph went upward. We have nothing here for our H because we didn't shift left or right. And since it's lifted up, that means that K was positive. Now we go down here to the last two examples. Now, first of all, since we notice, we can do this at the same time. We notice both of these graphs are facing downward. So we know that both of these graphs would be negative because they're facing downward. Now, if you notice here, let's look at the H. It's shifted to the right here. So if it's shifted to the right, that means that is positive. Now over here, it's shifted to the left. That means it's negative. Now, if you notice with the K here, it does go down. It's shifted down, so your K is negative. So it's basically shifted down or shifted downward. So your K is negative. Now, if you notice here, this does not leave the x-axis, so then your K is 0. And that is it as far as these graphs are concerned. Now, we come here. It says, which graph has the largest absolute value of A? We know that that's D. And we can explain by just looking that it's the most narrow. Now, let me scroll up so we could just look at all this on the video. Okay, you see how narrow D is. If you look up here at A and B, both of them are wider. And I'm not talking about whether it's going up or down. It's just which one is narrow. This is more narrower. So now we come here to the next question. Which graph has the smallest absolute value of A? Now that would be C, because C is the widest. Now we already know D is taken out of contention. What we look here at C. C is wider than A and B. So C will have the smallest absolute value of A. And this is it.